Welcome to Study Loop.
Let's start with the statement of this question. Now, it says that we need to find the values of A, B, and C if that is possible, such that the system of the linear equation has a unique solution, right? A unique solution, and B, if they have no solution, right? And C part, if they have infinitely many solutions, right? Infinitely many solutions. Fine. So let's take a look at the system of equations. So the first equation we have x plus y equal to 0. Then we have y plus z equal to 0. Then we have x plus z equal to 0. And lastly, we have a times x plus b times y plus c times z is equal to 0, right? So let's start with its statement. Now, the first step is to write down augmented the augmented matrix, right? So that is 1 1 0 0, right? Then we have 0 1 1 0. Then we have 1 0 1 0. And lastly we have a b c 0, right? So let's say that this is first equation, right? This is not an equation, but let's say that it's first, right? So that we can refer to it. Now what we are going to do is that we are going to use the Gauss Jordan elimination, right? Gauss Jordan elimination. And after that, we are going to do some row operations, right? So what we are going to do, the first step, the first operation, it's that we're going to subtract the first row from the third row, right? And we would get a new third row, right? And then other operation that we are going to apply over here is that we are going to um, multiply the um, fourth row with a negative 1, right? And then adding we would be adding um, the factor of a times r sub 1, right? So basically we're multiplying the first row with the a, and it would give us a new fourth row, right? So the augmented matrix that we wrote above, it would take this form, that is 1 1 0 0, right? Then we have 0 negative, sorry, positive 1, positive 1, positive 1 0. Then again, as we discussed, that we would be having a new third row, so it would be 0 negative 1 positive 1 0. And last we would have 0 a negative b negative c 0, right? So let's say that this is 2. Now what we are going to do over here is that we are going to now apply another row operation. So that would be um, to add the second row and the third row, so that we would get a new uh, third row, right? So our matrix, it would look something like this, right? So that is 1 1 0 0. And then we have 0 1 1 0. Then we have 0 0 2 0. And then we have 0 a negative b negative c 0, right? Now let's say that this is 3. Now what we are going to do from here is that we are going to um excuse me, right? So now what we are going to do is that we are going to apply another row operation, that is to divide the third row with 2, right? And it would give us a new third row, right? So let's take a look at this. Um, so we would have 1 1 0 0, right? Row 1 and row 2, they are remaining the same. There is no change in row 1 and row 2. However, row 3 is going to be changed a lot in this question, right? So as you can see, now this is the new third row, right? And again, the fourth row, we change it only once. So that is what it is, right? So that is our step 4. Now, for step 5, we are going to again apply a row operation, and that would be to subtract the new third row that we just obtained from the second row, and we would get a new second row, right? So it would give us, let me change the color, right? So we have 1 1 0 0. Now we are going to open a new second row, so 0 1 0 0. Third row 0 0 1 0, and the last row 0 a negative b negative c 0, right? So this is the fifth step. Now excuse me. Now we are going to, as you can see, all the rows have been changed except for the first row, right? So it's time to change the first row. So we are simply going to subtract the new row, second row, from the first row, so that we would get a new first row, right? And this would look something like this, right? Second row is 0 1 0 0. Third row is 0 0 1 0. And over here we have 0 a negative b negative c 0, right? So this is the sixth step. Now we are going to apply the last row operation, right? So that is r sub 4 negative a negative b r times 2, it yields us r sub 4, right? And then we would have the reduced row echelon matrix, right? So that is 1 0 0 0, right? Then we have 0 1 0 0. Then we have 0 0 1 0, right? And lastly we have 0 0 negative c 0, right? So that is the seventh step. Now we have the reduced echelon, um reduced row echelon matrix, right? Now by using the back substitution, we would have x that is equal to 0, y that is equal to 0, z that is equal to 0, and c that is also equal to 0, right? So then the system, for the first part, that it would have a unique solution, right? The first part of this question um, said that we needed to solve the question for a unique solution, right? Now, as we can see that c is equal to 0, but we do not have any value of a and b, right? So we would say that they are arbitrary a and b. Excuse me, what I'm writing. Uh, for arbitrary a and b, the system will have a unique solution, the trivial one, right? The trivial one. Now, moving forward to these B part, right? That said, the system has no solution, right? So as the system is homogeneous, right? The system is homogeneous. Excuse me. Yes, right. So it would it will always have a solution, right? It can never happen that the system does not have a solution. And the third part said that the system must have infinitely number of solutions, right? And since it's homogeneous, so it means that it can never have an infinite number of solutions.